Alright, so first I want to congratulate you on completing Math 2. We are now in crunch mode for exams. We have 5 days to get through everything in the entire course. One of the things that we're not going to go back over too much is probability because you just spent 2 weeks on that. So hopefully that's fresh in your brain. What we're going to spend time on are those things that we did way back in January, February, at the beginning of the semester and throughout. That may not be as fresh on your brain. So today we're going to start with properties of exponents, which is something you did a lot in Math 1, but I want to make sure you understand them so that when we get into the Math 2 review material, you still have them fresh on your brain. If you recall, there are a few properties that you should know. The product property is when you multiply variables with the same base, you add their exponents. So x to the fourth times x to the third is x to the seventh. The power property is when you raise a power to a power, and in this case x to the fourth to the third gives x to the 12th because you multiply those powers. The quotient property is the opposite of the product property. So instead of adding, we subtract. So x to the fourth divided by x to the third is x to the first, or just x. Please remember the rule is always top minus bottom. Zero property says that any number to the 0 is 1. So that can be any number big, small, any letter, anything. Lastly, negative exponents change direction. So x to the negative 3 can be written as 1 over x to the third, and 1 over x to the negative fourth can be written as just x to the fourth. If it's negative up top, it'll be positive in the bottom. If it's negative in the bottom, it'll be positive up top. Negative exponents change direction. Now take a few minutes and complete problems 1 through 6 using the exponent rules. Simplify them as much as you can, meaning each letter should only be written once, if at all, and every exponent must be positive. Pause the video and then check your answers. Alright, here are the answers for 1 through 6. If you have any questions, look at this work, listen to the explanation, and if you still have questions, ask Miss Lewis. Number 1, whenever we look at our x's, negative 3 minus 1 is negative 4. And then the y to the negative 1 times y to the 1 will just give me y to the 0, so the y's go away. So all I'm left with is x to the negative 4, which is 1 over x to the fourth. In 2, b to the 0 cancels up top. B to the 3/2 to the 0 cancels because that's a 0. So I'm just left with that b in the bottom. So that's 1 over b. Then the following work out similarly. In 3, you are subtracting exponents. In 4, you are distributing a power and subtracting exponents. In 5, you're distributing powers. And in 6, it's just very similar to 4. You're distributing powers and then dividing. So 3, your answer is 8x to the 3/4, or 4 roots of x to the third. We will talk about that form in just a minute with y to the 8th on the denominator. So if you said x to the 3/4 over y to the 8th, you're okay. On 4, it is 64x to the 1/2 divided by y to the 12th. You can write 1/2 as a square root power. In 5, we have w to the 4th, x to the 3rd, z to the 6th, the cube root of w squared, x divided by 4y squared, which again can be written as fractions. Number 6, you have 2y to the 14th over x to the 8th. If you have any specific questions on 1 through 6, please ask Miss Lewis before continuing on in the video. Next, you need to be able to go through exponential form, radical form, and its whole number. This is what the questions up top were referring to. If you remember, we talked about this as a to the m over n is the same thing as the nth root of a to the m. So here, 64 to the 2/3 is the 3rd root of 64 squared. 16 to the 3/4 is the 4th root of 16 to the 3rd. 9 to the 3/2 is the same as the square root of 9 to the 3rd. These reduce to 8 and 27. This first row has nothing to do with each other. Next, try the examples on the next page, 7 through 14, to see if you have any questions. Pause the video before checking your answers. Alright, so here, 7 through 14, here are your answers. Number 7 is 2. 4 to the 1/2 is 2, which is the square root of 4. 8 is also 2. The cube square root of 64 is 2. You can type these in your calculator if you want. 9 is 4. 10 is 4 square root of 2. You can jailbreak that problem. Break down your 32. Circle your pairs. In 11, you get 27. 12, you get 64. 13 is 64 square roots of 6, and 14 is the 15th root of b to the 4th, I believe. Is what this says. There's a lot of work for 13 and 14, so be very careful going through it. The easiest way to do these is to always change them to exponential form and then do your exponent. So for 32, the 4th root of 32 to the 3rd is 32 to the 3/4 power squared. Remember, we multiply exponent, so that's 6/4 or 3/2. So then I change it back to radical form, so it's the square root of 32 to the 3rd. 32 square rooted is 4 square roots of 2. If I do that to the 3rd power, that would be 64 square roots of 6 when it's simplified. 14 works out similarly. Put it in fraction form. And then subtract your exponents, find a common denominator, and then simplify that. If you have any questions on 7 through 14, please ask Ms. Lewis now. Next, solving radical and rational equations. Remember, our goal is always to get x by itself, and the easiest way to do that is to get rid of the exponents. So in 15, x to the 1/2 power, the way to get rid of 1/2 is to raise everything to the square, because 1/2 squared is 1. Well, 64 to the 1/3 is 4, so it would give us x to the 1/2 equals 4. When I square both sides, it gives me x is 16. In 16, the square root of x plus 4 equals 10. To get rid of a square root, we square both sides. So that would give us x plus 4 is 100. Subtract the 4, x is 96. In 17, we have x plus 2 quantity to the 4th power equals 16. The reciprocal of 4 is 1/4, so you can raise it to the 1/4 power, but remember that's always the 4th root. So that gives us x plus 2 equals 2, because the 4th root of 16 is 2, giving us x to be 0. If you have any questions on 15, 16, or 17, please ask Ms. Lewis now. Next, simplifying polynomial expressions. This is just adding and subtracting polynomials, maybe a little bit of multiplying. Remember, we are simplifying, not solving. X will not equal a number when you see the word simplify. Evaluate is whenever you get x equals a number. Simplify means just get it down to its smallest terms. So when we add or subtract polynomials, we rewrite the expression without parentheses and combine our like terms. X squared goes with x squared, x goes with x, but x does not go with x squared. Like terms are the same variables with the same exponents, not always the same coefficients. Remember, we keep it, switch it when subtracting, which is fancy for distribute the negative sign. Now take a few moments to do the 4 problems to make sure you understand how to add and subtract polynomials. Please pause the video while you do this and then check your answers. In the first one, you should get 12x minus 1. The second one should be 3x to the 3rd plus 7x squared minus 5x. Number 3 should be 6x to the 4th. Number 4 should be 8x to the 4th minus 6x to the 3rd minus x squared. All of these are written in descending order, which means that the powers of x go down from biggest to smallest. If you have any questions or missed anything, now's the time to ask Ms. Lewis. Next, we will talk about multiplying. You can FOIL or box when you're multiplying. So we are going to FOIL, box, or use the distributive property to multiply. Now take your time going through 5 through 8 and practice multiplying polynomials. Please pause the video while you do this before you check your answers. Alright, the answers to number 5 through 8 are 6x squared plus 48x, 8x squared minus 10x minus 7, 5x to the 5th minus 30x to the 4th plus 5x to the 3rd minus 50x squared. Goodness. And then 8 is x to the 3rd minus 8x squared minus 2x plus 7. In the first one, number 5, you just simply distribute. Same thing with number 7. You can just distribute the 5x squared, remembering to multiply coefficients, adding exponents. 6 and 7, you can FOIL number 6. However, you cannot FOIL number 8 because x squared minus 9x plus 7 is more than 2 terms. So on that one, I did the distributive property, but you are more than welcome to box it. If you have any questions on 5 through 8, please ask Miss Lewis now. 9 and 10 give us real-world examples of polynomials. This is more than likely how it will be asked on your state exam or the county exam, whichever one. Number 9 says a rectangular athletic school field currently has a length of 25 by 5. They're going to expand both the length and width by x yards. Write a polynomial that expresses the new area. So we have a 25 by 5 rectangle. We're going to add x to each side. Area is length times width, so all I would do is multiply these two. So 25 plus x times 5 plus x would give me x squared plus 30x plus 125 as its area. Number 10, the perimeter of a trapezoid is given. 3 of the sides have the following lengths. What is the length of the 4th side? So what we do to solve this is I have 3 out of the 4, so I'm going to add those up. 9a, 5a plus 1, and 17a minus 6 is 31a minus 5. I know everything adds up to be 39a minus 7, so I'm just going to subtract those two to see what my third side has to be, which is 8a minus 2. If you have any questions on these real-world examples, now's the time to ask Miss Lewis. Try number 11 on your own. If you have any questions, ask. Please pause the video before doing the problem. Alright, number 11, says a company's logo is white square inside of a red square. The length of the white square is x plus 2. The inside of the red square is 3 times its length. So 3 times x plus 2 would be 3x plus 6 because you have to multiply the 3 to both of them. What is the area of the red part of the logo? So remember, it's red all out here and white inside. So we're going to take the bigger rectangle or square, and subtract the smaller square. So area is still length times width, and a square has the same for its length and width. So that's 3x plus 6 times 3x plus 6, which gives us 9x squared plus 36x plus 36. Our smaller white square is x plus 2 times x plus 2, which is x squared plus 4x plus 4. And we're going to subtract these two to see what the outer red area is. When you subtract those two polynomials, you get 8x squared plus 32x plus 32. The next thing we're going to talk about is factoring. Factoring is a big deal in Math 1, and it's understood you know how to do all these methods in Math 2. Please remember, we always factor out a GCF first if there is one. And remember, GCF is greatest common factor. If they're all even, we take out a 2. If there's a variable that they have in common, we take that out. Factoring out the greatest common factor makes our life a whole lot easier. Binomials means there are 2 terms. If there are 2 terms, we're going to check for the difference of perfect squares, meaning x squared minus 9. Things we can take the square root of are perfect squares. And difference means we are subtracting in the problem. There's no such thing as the sum of perfect squares. So x squared plus 9 is prime. You cannot factor it. If we have trinomials, meaning 3 terms, we're going to try the big X or we're going to slide and divide. Remember, the difference between big X and slide and divide is whether or not you have an A term. If A is 1, we're going to use big X. If A is not 1, we're going to slide and divide. If we have 4 terms, we're going to factor by grouping, which is where you split it down the middle and do GCF twice. Be careful and watch for a minus sign when separating the binomials. Now take a few minutes and do the factoring problems, which are up to number 23. Pause the video and check your answers later.